Now we will see about commutators. The commutators, to study the commutators, firstly we see a very important postulate in quantum mechanics that states any observable quantities like kinetic energy, potential energy, momentum in classical mechanics have an operator associated with them in quantum mechanics. So what does it mean? For example, we have momentum p. For example, we have momentum p in classical mechanics, which is physically observable quantity. That is, we know p is equals to mv. If we know mass, if we know velocity, we can find momentum. But when we talk about momentum in quantum mechanics, then p momentum has an operator, and then it equals h cut eta d over dx. We know h cut is equals to h by 2 pi. Eta is any imaginary value and d over dx is differential. We can also write it as p operator is equals minus eta h d over dx, h cut. So how we get this minus eta? If we multiply and divide this value with eta, let me do it here. Eta over eta d over dx, we will get eta h cut over eta square d over dx. We know eta square is equals to minus 1 and minus eta square is equals to 1. So we will put this value over here and we will get minus eta h cut d over dx. It is same as this one. Now we will see position operator. The position in classical mechanics we can say it as x, but in quantum mechanics we will take position with operator and we will get x. The third one is kinetic energy operator. The kinetic energy operator is equals p square operator over 2m. As we know, p square is equals this one, so we will write it as h cut square eta square 2m d differential and differential x square. If we solve it, then we will get h square over 2m. This eta square will convert into minus and d square over dx square. This was all about commutators and in classical mechanics and quantum mechanics. We have seen the postulate. Now we will move forward Hamiltonian operator. As we know, Hamiltonian operator Hamiltonian operator we denote it as h cap. We know that h cap is the energy operator. If it acts on particular wave function of any system, it gives energy of that system. It is sum of kinetic energy operator plus potential energy operator. We have seen about momentum in classical mechanics and in quantum mechanics, position in classical mechanics and quantum mechanics, kinetic energy in classical mechanics and quantum mechanics. And we have known about Hamiltonian operator, that is Hamiltonian operator gives energy of system, and the energy of system is equals to kinetic energy with the sum of potential energy. So it was the general introduction. Now we will move for what actually is commutator. Suppose we have any p operator and any x operator. Now we are studying about what actually is a commutator. We have supposed that we have p operator, momentum operator, and x operator, position operator, that act on any function f of x. We can write it as p operator, x operator acting on function fx. We can also see after changing these positions. If I write position operator first and momentum operator after, acting on function of x, we have just changed the position of operators. Now we will solve these operators. Okay.